This problem, we can see the red shaded circle, center of this circle is O, and there is another triangle within this circle, which is A, B, C, and B is the right angle. So this triangle ABC is a right angle triangle, and obviously O is the center of this circle. And the length given to solve this problem, that is the length or the perpendicular of this triangle from A to B is 3 unit length. From A to D is the point where actually the circle and the triangle intersect each other. So up to A to D is 3, and from D to C is 1 unit length. So what is our target? Our target is to determine the radius of this circle. Indeed, we have to know a couple of theorem which is referred to circle and the triangle. Let's start. Here, one important thing we have to tell you that this diagram may not 100% true to the scale. It means that some of the length may be not accurate or not exact as it is we said. This is actually a hypothetical data as given. Let's start, right? Very first step, we have to understand an important theorem which is related to tangent within a circle, which is actually tangent secant theorem. What is actually the tangent secant theorem? If a tangent line, a line touching the circle at just one point, it means that, say, there is a tangent from P to A. So A is the touching point, and second line, a line passing through this circle at 2 points. It means PC passing through at B point, at C point. Their length have a spatial relation. And what is the relation defined by the tangent secant theorem? That is actually the PA square is equals to the another tangent which is actually touches 2 points of the circle, which is PB, and extended to PC. So this PC. So this is actually the tangent secant theorem. Now, if we apply this theorem within this math, what we can see? Let's take this part from the original diagram. So this is the circle red, and the part of the circle, part of the triangle, the tangent EC, and C to D and A, 2 points, as I said, for this theoretical diagram. Here we represent, before it was B point and C point we described. Now here 2 points, one is point D, another one is point A, and the very first tangent line and touches 1 point at E, and C is the initial point. Indeed, we could write down by the definition of the tangent secant theorem for this image, that is CE square is equals to CD times AC or CA. Now it's time to plug in the value of CD. What is the value of CD? That is actually 1, and AC is from here to here. So AC is 3 plus 1, that is 4. So CD is 1 and AC is 4. So CE is equals to square root under 4. So CE is 2 unit. So this length from E to C, this is actually 2 unit length. So up to CE is actually 2 unit length. Now what we have to do, we have to apply Pythagoras theorem for triangle A B C. Indeed, the hypotenuse AC square is equals to AB square plus BC square. What we have to do, we have to determine the value of BC. So BC square is equals to AB square, AC square minus AB square. Let's plug in the value of AC. AC is of course 4 square minus AB is 3 square. So BC is equals to square root of 4 square minus 3 square. So it will be 16 minus 9 square root. So BC is equals to square root of 7. So from here B to C is square root of 7, right? And we already have the value of CE. It means, let's change the color from CE, that is 2. So BE will be, so BE will be, this length will be square root of 7 minus 2. In this step, we already found the value of BE is square root of 7 minus 2. So same as we extend from the center of this circle O to perpendicular of the AB line, that is OF, this is same as BE. So we can write down BE is equals to OF is equals to square root of 7 minus 2. And of course, the connected line from O to E is the radius of the circle, because O is the center of the circle and E is touches the circumference of a point. Indeed, this is the radius of the circle. So these are, we have to determine, this is our actually main goal, right? And of course, FO or OF and B, we have got the value square root of 7 minus 2. Now what you can do, we know the length of AB is 3. So AF equals to, we can write down the total length is 3, and of course OE equals to BF. This two length is of course parallel and equal. So this length and this length is equal and parallel. So this is R. So AF equals to, we can write down 3 minus R. So actually AF is 3 minus R up to this length, right? Now it's time. Now it's time to add this length from A to O. So there is a triangle, triangle A F O, and of course at F point this is 90 degree, and we have got the value FO as well as AF, and AO is the radius of the circle, right? So if we apply Pythagoras theorem for the triangle AFO, what you can write? AO square. So the green line AO square plus FO square, the base, and the perpendicular is AF plus AF square, right? Now plug in the value. So AO is R square equals to FO is square root of 7 minus 2 whole square plus the value of AF is equals to 3 minus R whole square. Now simply solve this equation. Let's work together. So this will be R square and this will be 7 minus 4 square root of 7 plus 4 plus 9 minus 6R plus R square. Both side R square cancel. What we have to determine? We have to determine the value of R. Indeed, let's change the side of the equation. So 6R will be in left side and rest 7, 4, 9. It will be 20 minus 4 root 7. So R is equals to, let's take the common part of 4. So it will be 5 minus square root of 7 over 6. So this one will be 2 and this will be 3. So 2, 5 times square root of 7 over 3. So R is equals to, so numerically we can write down 1.57 unit. So this is the final answer, the radius of the circle. So the radius of this circle, which is actually OE or maybe AO or maybe any length, doesn't matter. So the radius of this circle is 1.57 unit. So this is the final answer for the problem.